Hi everyone. Today in this lecture I will continue mathematics of biomechanics. Let's understand the principle R mechanics. In this video we will look at some of the R mechanics calculation. Once we complete R mechanics calculation, we will go for further analysis of R mechanics. What and where do we use R mechanics? We will see all the questions once we finish mathematics of R mechanics. Let's see what are the steps of R mechanics. With the given quadratic equation, one need to calculate roots of quadratic equations. Once we have the root of quadratic equation, we need to calculate the desired polynomial. Once we have desired polynomial, we need to multiply the desired polynomial with the primitive polynomial. Division of desired polynomial. In fact, I should write division of primitive polynomial to the desired polynomial. Don't worry, I will take an example. Then we need to calculate dual polynomials. Once I have the dual polynomial, I need to divide it by x and x square. Coefficient of step number 6, that is division x and x square, will give me R mechanic polynomial. I hope you understood. Let's take one example for further clarification. Find out, look at the question, find out R mechanic value. Sometimes they call it as value, sometimes they call it as R mechanic polynomial for a given quadratic equation. So let's take x square plus 2x plus 1 equals to 0. Okay, in order to calculate first step is to, what is the first step? Is to calculate the roots of quadratic equation. So coefficient of x square is 1, coefficient of x is 2, and this is the constant term which is c. So therefore a is 1, b is 2, and c is equals to 1. Therefore b square minus 4ac, which is equals to d. B is nothing but 2 square minus 4, a is nothing but 1, c is nothing but 1, which is equals to 0. Now what are the roots? Which is equals to b plus minus under root d divided by 2 of a, which is equals to, b's here is 2 plus minus 0. Okay, this term is d, remember, and a is nothing but 1. So this is 2 by 2, which is equal to 1. we have x is equals to 1, or I can write as x square plus 2x plus 1 has root x is equals to 1, x is equals to 1, or I can write it as x minus 1. This is my one root value. Let's go to the second step. So we have done with the step number 1, that is the calculation of roots. Next is the calculate the desired polynomial. Look at this. We have x is equals to 1. Now how to calculate desired polynomial? To calculate the desired polynomial, write it as x bar 0, 1, 2, 3, 4, 5, 6 and 7. Okay. Now we have given x is equals to 1. X is equals to 1. Why I have written like this? Look at this. I have given x to the power 1. Here also x to the power is 1. Make others as zeros till 8 bits. Okay. Look at this. There are 8 bits is here. Correct? So we have a desired polynomial for x equals to 1, that is x bar 0 till x bar 7. X bar 0 is nothing but 0, 1, 0, 0, 0. This is due to x power 1. 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. So we have 0, 1, 0, 0, 0, 0, 0, 0. Now you complement this function. Complement this function, which will be 1, 0, 1, 0, 1, 1, 1, 1, 1, 1. Now rewrite x bar 0, x power 1, x power 2, 3, 4, 5, 6 and 7. It means my desired polynomial is x power 0, or I can just write it as 1 plus x bar 2, x bar 3 up to x power 7. This is my desired polynomial. Please remember that sometime they may ask directly for the desired polynomial. So we have completed our second step. Let's go to the primitive polynomial. Okay. For a given solution, we need to find out the primitive polynomial. For a given equation, we need to find out the primitive polynomial. Okay. Now, how to find out the primitive polynomial, which is nothing but c of x into g of x. What is my c of x value and g of x value? Okay. So, what is my primitive polynomial? Primitive polynomial is given by multiplication of mechanic value into desired value. This we have studied in the previous video. You may refer it. Fine. We have given the desired value. We have given p is equal to desired is given. Okay. Since mechanic polynomial is not given, we can consider mechanic polynomial equals to 1. It means polynomial p is equals to 1 into 1 plus x square till x power 7. I can write it down. Desired polynomial equals to primitive polynomial is equals to primitive polynomial. Now what, okay, in GATE they may ask when primitive polynomial equals to desired polynomial. They may ask this question. So we know very well, when mechanic polynomial equals to 1, under that condition primitive polynomial will be equals to desired polynomial. Okay, now what's the next step? Let's see the next step. So we have primitive polynomial. Now division of primitive polynomial to the desired polynomial. We know it very well. What will be the outcome? Solution. What is the next step? Division of primitive polynomial to the desired polynomial. We have seen 1 plus x power 2, yes, till x power, I should write till x power 7 divided by 1 plus x power 2, this is divided by x power 7, which is nothing but 1. So it means our division value equals to 1. I hope this is clear. Let's go to the next step. We have this division calculation with us. Now we need to calculate dual polynomial. We need to calculate dual polynomial. What is dual polynomial? How to calculate dual polynomial? How to calculate dual polynomial? Let's see. Now we have division value equals to 1. When division value equals to 1, it means a dual polynomial is x plus 1. When division polynomial value not equal to 1, it means dual polynomial is x power plus 2. Now in order to calculate subdual polynomial, we need to form a table and we need to write x power 1, 2, 3, 4, 5. Let me extend the table. 6 and 7. Okay, this table is called as primitive dice polynomial. Okay, this table is called as primitive dice polynomial, right? Of 0 and 1. So okay, this table is the basic table you need to remember all the times. Okay, what we got is in the previous, okay, we have x and 1, correct? X and 1, can I write it like this? X plus x power 0, x plus x power 0, it means I have the value x power 0 as 1, this as 1. Okay, let's go to the previous section and see what we got as primitive polynomial. We don't have x power 1, but apart from that we have everything, correct? This is my primitive value and this is my dual value. Okay, all are zeros. All are zeros. Now what I need to do is, when it is 0 and this is 1, this is invalid, this is 0, this is invalid, It means only these zeros are valid. Okay, now let's see, this is 1. It means only these are valid. Others are not valid. Okay, now look at this. We have in our solution, what do we have? We have x for 0 and for 1. What do we have? We have x power 2 till x power 7. Here we have 1. This was 0, so this was also invalid. X power 0, x power 2, x power 3. X power 0, sorry, this should x power 0, x power 2 and x power 3. Okay, now we will take the one which is common. Okay, so x power 3, x power 4, x power 5, x power 6. Let's see this. X power 2 is there, correct. X power 3 is there, but 3 is there, but x power 0 doesn't exist, and those doesn't exist. So we have x power 2 plus x power 3 as our mechanic polynomial. Very important question. They may ask this question. Okay, so you may prepare and you may try out some other problems. They may give very shorter numerical values. They will not judge your calculation. They will give you some small they will give it very simple. The one which I had taken was too simple, but you need to practice once. It has some steps, so I hope you understood. So you need not to refer this is another procedure. You may refer the procedure which I have done it. That procedure is actually much simpler. Okay, you may skip step number 5, 6 and 7, and you can refer the steps which I did, but in the textbook they have mentioned step number 5, 6 and 7. I hope you understood. If you have any doubts, you may write it in the comment section. I will address your issues. Thank you.